Thanks everyone for the time. We've been doing these short tech talks about once a month. We're going to try to do it around the same time and keep it at 30 minutes or less. And the goal is to share experiences and lessons learned from a variety of pen tests and attacks and exploits that we've been going through over the past few months or over the past 6 months or maybe longer. And today what we're going to talk about is Log4shell. So what's interesting with Log4shell, and we'll start sharing some slides here, is just how often we're still running into Log4shell as a set of issues. So I think about Log4shell as really Log4hell. When you think about Log4shell, first, it was discovered back in November of 2021. Like all good CVEs, they usually come out right around the holidays so that we end up burning our nights, weekends, and vacations dealing with it. And what made Log4shell incredibly dangerous were kind of a couple of factors, but the big thing is it allowed for arbitrary code execution that was triggered by a very simple payload, a very simple JNDI request. So throughout 2022, about 20% of the pen tests that we ran successfully exploited Log4shell to get code execution, and then use that to go off and become domain admin or gain access to sensitive data and beyond. And in 2023, it's still a pretty high number. 13% of the pen tests that we execute exploit Log4shell in some way as a launch point to go off and achieve a critical impact. When you think about how Log4shell works, it's a pretty straightforward attack and it's pervasive. So the first thing an attacker is going to do is send a crafted JNDI message to an application. Now think of a website form fill where you've got to put in your name, first name, last name, email address, and comments. Well, that form fill is likely implemented in a web application, and the developer took that form data and logged it through a logging framework. And that logging framework is in Java applications is most likely Log4j. It's just a very common, popular framework that's out there. It's open source, it's pervasively used. It's also bundled in lots of different vendor products. In fact, most organizations probably can't even accurately count the number of instances of Log4j being used because of how deeply embedded it can be. So when an attacker crafts a very specific payload, it looks like this $sign JNDI string, and then the attacker's host address and their port, and they're going to put that in any of the form fills that exist in any of the applications that they've identified. That web application is going to log that string, and that string is going to trigger an outbound call to a malicious server listening for these types of requests. And that's typically going to be done over the RMI protocol, which is an atypical outbound protocol within an organization, but it's a protocol that people don't necessarily pay attention to either. And once the attacker receives that outbound beacon, they're able to send commands and get code execution on the host, on the log server host, and then from there start to gain access to sensitive data, start to execute commands, live off the LAN, and start to compromise the environment. And this is the primary goal, is to get code execution on the logging server that logged that malicious payload. The other thing that Log4shell can be used for is to gain access to sensitive information like environment variables. So when you think of a slight modification to that attack flow, an attacker is going to send that malicious payload, that JNDI string, and they're going to be able to put in additional parameters that are looking for likely environment variables that they can pull from. In this case, the AWS access key ID is an environment variable name that is commonly found, and that is going to trigger the log server to log that statement. It's going to trigger that malicious payload, and then the attacker is going to get that AWS access key as a value in their response of this particular attack. So it's not only getting arbitrary code execution, but it's also harvesting very sensitive information that can be used in subsequent attacks. So what I'm going to do is talk through a few of these attacks, and as you guys have questions or comments, please just fire them up in the chat, and then we'll answer those questions along the way. And hopefully we've got time to open it up for discussion as well, because that's half the fun with these tech talks, is to actually engage in dialogue with the community. And perhaps this might be better served as a Twitter space or something down the road. So when you look at examples of attacks, the first is the different methodologies that attackers are going to use, and in this case, what Node0 uses in exploiting Log4shell. So the first approach is going to be fuzzing custom applications. What I mean by fuzzing is back to you've got a custom web application, it's got that form fill or some sort of login prompt or any sort of text field that is likely going to be logged in Log4j. And what fuzzing does as a tactic is it's basically throwing malformed or semi-malformed data into those form fills in an automated way. And it's spraying and praying to see which of those form fills triggered that outbound beacon that shows Log4shell is exploitable in that environment. So this is what you'll see attackers do for your custom applications, is spray and pray fuzzing through automated attack techniques. The second thing attackers do is go after very targeted applications that are unpatched or difficult to patch or are in well-placed locations in the network. And so examples of these unpatched applications that we've successfully compromised and that we've also seen ransomware organizations compromise include vCenter, Elasticsearch, OpenNMS, Ubiquity, Unified Networks, and so on. These tend to be application services or virtual appliances that sit in trusted locations in the network, or in the Unify example, can sit on the perimeter that gives the attacker the ability to breach the network. And in this case, it's going to be far more targeted and also far easier for the attacker to quietly get in and out, because vCenter is by far the most common product we're able to successfully exploit with Log4shell, in part because it's sometimes difficult for organizations to patch that particular product. But that's kind of the consistent theme that we see amongst these targeted applications. They're difficult to patch because they're critical infrastructure with very strict maintenance windows, and they're well placed in the network and oftentimes have access to service accounts and other privileged credentials. So if you do get host compromise, it's a very juicy set of follow-on steps. So I'll give you a couple of examples. So the first one is breaching the perimeter. And when you think about Log4shell as it leads to a host compromise, once they've compromised the host, if they've breached the perimeter or gained initial access, they're going to start to do common techniques to achieve their objectives. So once you've compromised a host using Log4shell, the attacker is then going to execute common techniques in order to harvest credentials, find misconfigurations, exploit dangerous product defaults, exploitable CVEs, and then combine those together in different ways to become a domain admin, to compromise hosts, to become a domain user and gain access to sensitive data, and so on. And if you look historically, at least across our now 22,000 pen tests that we've run over the last 18 months, the top 10 techniques that we've been able to use to successfully compromise the environment are listed here. Where once you've gained host compromise, you start to look for brute forcing of weak and default credentials. You start to dump credentials and reuse them across Windows and Linux hosts. You are starting to do man-in-the-middle type techniques to harvest NTLM hashes that you can relay or crack. You are looking for misconfigurations that will, on virtual appliances that are well placed like HP ILO or Dell iDRAX. And 9 out of the 10 techniques commonly used have nothing to do with CVEs. Only one of them, number 10 listed there, might be those critical vulnerabilities that we see in the news. So once an attacker is able to successfully exploit Log4shell, they've got host compromised in the network. Now it goes back to the basics for the attacker leveraging these types of techniques to compromise you. So here's the first example, which was using Log4shell as an exploit against the Unify network controller in order to lead to a perimeter breach. So what an attacker is going to do, in this case Node0, is they're going to start from the outside. They're going to inventory or map your external attack surface and then fingerprint the Unify controller. And then you're going to see it's running Nagios and a few other services and ports. And there's a variety of techniques you can apply to fingerprint that this looks like a Unify network controller. And then from there, you're going to craft that malicious payload, push it into the admin console of that unified controller, and then you're going to look for, as an attacker, that callback. Now, I've masked that data out because this is from a real customer environment. But what you're going to look for is that LDAP beacon out that gives the attacker, in this case Node0, remote code execution on that particular host. And upon doing so, Node0 or an attacker now has initial access in your network. And in this case, it took less than 2 minutes for Node0 to identify a way to breach the perimeter of this particular customer. And this is a key part of security strategy in general. There are so many doors and windows that allow for an attacker to break in that you have to assume breach. In this case, less than 2 minutes for the attacker to break through the perimeter and gain initial access into the network. Outside of Log4shell, there are attacker organizations that make money gaining initial access, sitting on that initial access, and then selling it to the highest bidder or to ransomware organizations, and then they do profit sharing on the outcome. So the fact that we were able to breach the perimeter in less than 2 minutes using Log4shell against a unified controller, while it's scary to think it's less than 2 minutes, it's not at all surprising given that there's so many ways for an attacker to get in. And what you'll see here is the command that we executed and then the output proving that we're able to get the LDAP callback after getting code execution on that particular host. So once an attacker gains initial access, from there, they're going to be able to inventory or conduct recon and enumeration within your environment, and then start to identify hosts, ports, services, credentials to harvest, and so on, to do their follow-on attacks. Another example is as the attacker gains initial access, now they're on the inside, that attacker is going to start fingerprinting those targeted applications. In addition, they're going to be fuzzing at scale. The only issue is when you're fuzzing at scale, you're much more likely to trigger some sort of defensive tripwire, illuminating that to the SOC that the attacker's in the network. So it's not necessarily fuzzing at scale in a huge noisy way that you're going to typically see an attacker behave. Instead, you're going to see the attacker behave in a far more targeted manner, looking for specific applications that they know they've got a very high likelihood of being able to compromise. So in this case, VMware vRealize, although as is mentioned earlier, vCenter is by far the most common product that we're able to successfully exploit using Log4shell. When we look at how that works within vCenter, what you have in here is Log4shell code execution on a VMware vCenter environment. So Node0 is going to fingerprint. It's going to find that there's a particular web service running. From there, it's going to fingerprint that web service is actually part of the vCenter application environment or vCenter product environment. And then from there, successfully craft that JNDI payload unique to vCenter to compromise it. And what that looks like is essentially, this is the command that we've executed. This is the request payload. And then this is the response that we're getting, which is basically the beaconing back saying we were able to gain initial access. From there, the next step is to prove that we could get code execution. So usually these web applications or these types of products like vCenter are running an embedded application server or an embedded web server. Usually that embedded web server is Tomcat. And so now what you're able to do is assume that it's Tomcat under the covers and then start to execute code execution to get PowerShell commands or other types of techniques on that underlying host. So in this case, we're able to prove we got code execution by running a curl command on the target and getting outbound web calls. And then finally, what you're going to see an attacker do is prove that they're able, or this is getting the JNDI connection, is prove that they're able to get access to sensitive environment variables. So once the attacker has code execution, they're going to be able to drop in a command and start to pull out sensitive information. What Java version are you running? What's your class path? What type of machine are you on? In this case, it's fairly basic Java pieces, but you'll find that AWS user account name as an environment variable if you're running in the cloud, as an example. you might find other sensitive Java runtime parameters that get passed in upon JVM init as another example in there. So what's important as you think about Log4shell is that in this case, once the attacker gained initial access, in 18 minutes, they were able to discover, fingerprint, and exploit VMware vRealize to get code execution on that box. So you're talking about a total attack time end-to-end of about 20 minutes from breaching the perimeter through a Ubiquiti network controller to then finding VMware vRealize or vCenter to gain code execution. And then oftentimes on these servers are highly privileged accounts, your service accounts, domain user accounts, domain admin accounts, and so on, that the attacker is now going to be able to dump credentials and reuse across the board. Another example, when you assume compromise and the attacker gains initial access into your network, is being able to harvest credentials or harvest sensitive information and then pivot to other parts of the environment. So in this case, Node Zero uses fuzzing as a technique to send a JNDI payload to an application that it found that had a web app in a form fill. And through that fuzzing process, it was able to gain code execution on that particular host. This is a custom application that was running on a Kubernetes cluster. The Kubernetes part doesn't matter. It's just a custom app that was running that was using an exploitable log4j jar file under the covers. And this was as recently as April of 2023. So you still have, as an enterprise, exploitable log4j jar files a year and a half after this problem has been identified. But what's interesting here is that upon getting code execution, that particular server had sensitive processes that could be dumped. So upon gaining host compromise, Node Zero was able to dump credentials, so dump SAM, dump LSAS, other sensitive processes on that box. Within those sensitive processes was the AWS access key that Node Zero was able to use to gain access to the production cloud environment. And then once you're in the production cloud environment, there are a variety of techniques to elevate privileges, gain access to sensitive data, exfiltrate S3 buckets, other things like that. So the important point is Log4shell isn't the destination. That's not the outcome. It's just the starting point for the attacker to gain initial access into your environment, whether it's breaching the perimeter or gaining initial access on the inside, and then using those 10 techniques I talked about earlier to harvest credentials, laterally maneuver, elevate privileges, and fully compromise the environment or gain access to sensitive data. And so you've got to treat this as a starting point and continue to invest in making sure that you've got the ability to detect and respond to those other types of techniques. So now what I'm going to do is zoom into post-exploitation of Log4shell. So now that you've got host compromise, what are typical things that an attacker is going to do? So the first example is, say Node Zero gets code execution on that single machine, that VMware vRealize box. From there, it's going to conduct recon and enumeration to find every host port and service that's network reachable from that location. Now, hopefully, the organization has some sort of EDR or detection and response type tools in place. In this example, the customer had Fortinet installed as their EDR, yet Node Zero was still able to get code execution on an adjacent machine, dump credentials from that machine, and then reuse those credentials to log into a machine next door. So the big question is, how on earth did that happen? One, how did Node Zero get code or initial access? But after that, why was Node Zero able to freely maneuver throughout the environment despite Fortinet being installed? And the answer was that the Fortinet agent actually wasn't properly installed on 3 out of the 5,000 machines in this environment. And remember, attackers only have to be right once. Defenders have to be right every time. And this customer had no idea that the automation process to install those agents had failed on those 3 boxes. Imagine this at scale with 10,000 or 100,000 hosts or even more. So don't trust that your tools are working. You've got to verify them. Now, it's not just Fortinet. If you're a Trend Micro customer, by default, OS credential dumping protections is turned off. And that's a very important advanced feature in antivirus products and in EDR solutions, all the big ones, that is used to prevent LSAS and other critical processes from being dumped. And so don't trust that even though you've bought the tool and installed it, that it's configured correctly and capable of preventing credential dumping and other common techniques that are being used. The next big issue here is, why didn't Fortinet stop the credential pivot? Because all the marketing brochures and literature said it should have. And it turned out that this particular customer didn't purchase the right modules to stop to do user behavior analytics detection and credential pivoting. That was an awkward conversation, but it's not something unique to Fortinet as a vendor. This actually happens all the time, where what you think the product does and what the product actually does isn't the same. And so you don't want to just trust the marketing literature or trust that the team purchased the right components or configured the right modules. You want to be able to attack through pen testing to verify that you are in fact protected against those common techniques. The next example is the attacker gains initial access, so Node 0 exploits Log4shell on a single machine. From there, what the attacker is going to do is start listening for NTLM hashes being passed along the wire. And this is due to LLM&R misconfigurations or NBTNS misconfigurations. What that really means is in a DNS lookup, there's a common misconfiguration that allows for multicast DNS. So service 1 is looking for service 2. Service 1 says in a multicast message, service 2, where are you? And it's going to spray that out to all of the hosts in that particular domain. Service 2 is going to hear that request and then reply back, here I am, please authenticate with me. In which case service 1 will push the NTLM hash over to authenticate. What DNS poisoning will do, or man-in-the-middle type techniques, is maliciously respond to all of those NTLM hash or multicast DNS requests. And so as an attacker collects enough of these NTLM hashes through that poisoning technique, you have enough hashes to start cracking those passwords. And oftentimes you're going to be able to use public information about the company, common password patterns, and so on to crack those NTLM hashes. And once you've cracked those hashes, you're able to access business email. If you have multi-factor authentication turned on, then the attacker can use those hashes to access services that cannot be MFA protected, SMB protocols, lower level protocols in the system, printers, other targets that have additional sensitive information. And what we found consistently was that 80% of the hashes that we collected are cracked in 15 minutes or less using straight up normal GPU rigs and standard computing, nothing fancy. 80%. 6% of the passwords that we were able to crack were based off of the company name in some way. 10% of the service accounts had the user ID and password as the same. So WebSphere admin, WebSphere admin, VMware admin, VMware admin. 26% of user accounts had some template to the password, whether it's a keyboard walk or some combination of the name and a sensitive number. And then finally, there was password reuse aligned to regional teams. So if you're from Boston, your password template is going to be something about how awesome the Patriots are or how terrible the New York Giants are. And if you're in Atlanta, it's how awful the 28-3 loss was to the Patriots. As a Boston fan, I work that analogy in everywhere I can. So attackers don't have to log in or don't have to hack in using 0 days. They are able to just log in using credentials that they've harvested after gaining initial access. Once again, as we saw, 2 minutes to break through the perimeter and then 18 minutes to get code execution on vCenter, and then dump credentials or harvest those credentials or use man-in-the-middle techniques to be able to do the follow-on steps in a compromise. The third story here is attacker gains initial access on that vRealize box. They fingerprint a bunch of hosts that are in the network. From there, an attacker is going to fingerprint juicy targets that are difficult to patch, like HP ILOs. If you're an HP storage customer or a Dell storage customer, you've got these virtual appliances that are used to manage those storage clusters. HP ILO being one of them. It's a virtual appliance with a custom operating system. That custom OS is difficult to patch, difficult to monitor and observe, and attackers know this. So those are the kinds of services that they're targeting. So in this case, Node 0 gets code execution on HP ILO. From there, ILO stores all of its credentials in clear text. So Node 0 is able to dump that process and get the clear text credentials, and then reuse those credentials to log in as a domain admin on the neighboring machine. And from that neighboring machine, start to pilfer the file system looking for sensitive information. And in this case, Node 0 is able to find the credentials file for the production AWS instance. So if you string this together, Log4shell to breach the perimeter using that Ubiquiti Unify network controller in 2 minutes. 18 minutes later, get access to host compromise on a vRealize instance. From there, look for HP ILO, compromise and dump those credentials, and then from there, take over the cloud environment. And these are very common ways to stitch together different phases of an attack to get domain compromise, sensitive data exposure, and full cloud compromise in an organization. I'll leave you with, in terms of the post-exploitation stories, how all of these pieces get strung together. So once an attacker is able to gain initial access, they're going to start using open source intelligence to start harvesting likely credentials. So if you go to LinkedIn, you can get a list of all of the employees that work at your company. And then you can go to Google and quickly figure out that your email, corporate email, is first initial last name at company.com. So you now have 1,000 or 5 or 10,000 likely user IDs to be able to log into a system. From there, all it takes is one of those users to have a weak password, whether it's a password they reuse from their personal systems that have been breached in their corporate environment, or some keyboard walk that we talked about earlier. And that attacker is going to become a domain user in the environment. And once you're a domain user, most likely that domain user is a local admin. And once you're a local admin, you can dump SAM, grab NTLM hashes, execute credential reuse, and snowball your way through. And eventually start to dump LSA, LSAS, and other sensitive processes and find a domain admin credential. Now, this is in the non-Log4shell example, but these same tactics are used by attackers upon leveraging Log4shell as that initial access vector into the environment. And there's no easy button to stop this. There's no magic defensive AI tool that's going to stop all of these types of tactics from being combined. It just comes down to the basics. Poor password policies were in place. Local admin privileges weren't properly managed. The Active Directory groups are too permissive because the domain user is also the local admin. The antivirus or EDR wasn't configured correctly to prevent OS credential dumping, or that the products were misconfigured, or critical services just weren't patched. So Log4shell gets an attacker in with ease in a way that is oftentimes invisible to the SOC. And then from there, it's chaining together tactics that are not CVEs to become a domain admin in the network. And in our pen test, we're able to compromise an environment in 4 minutes. It took an MSSP 7 hours to detect and respond to a particular attack. And most user behavior analytics tools actually struggle to be effective in production because most organizations lack the pristine logging data required for UBA tools to be effective. So I'll leave you with the most important point here. Being vulnerable doesn't mean you're exploitable. So if you take Log4shell as an example, and back to that original workflow, there's 2 ways to fix this. Option 1 is to go off and patch the application that's vulnerable, whether it's vRealize or vCenter or whatever else, which might be difficult to do based on maintenance windows. Or you've got to update the log4j jar file in all of your custom applications to prevent that fuzzing technique from being applied. If you've got 1,000 Java apps, that's 1,000 apps that have to get updated, all with different maintenance windows and patching cycles and different levels of DevOps maturity. That becomes very daunting, especially over the holidays in a crisis when Log4shell first came out. The other thing you can do, though, is put in a single network rule that prevents that outbound beacon over RMI from being established. That single egress control stifles this entire attack. So where I got frustrated as a practitioner was seeing application teams having to work nights and weekends to scramble patching and updating the log4j jar file when all they had to do was put in a single egress control. But because many organizations are very scanner centric or scanner dependent, those scanners will look for the potential vulnerable jar file, but they don't actually do the exploitation. And because they don't do the exploitation, you cannot easily prove that that you are vulnerable versus exploitable. So with Node 0, you're able to execute the actual Log4shell attack, where we will trigger that outbound beacon, and from that outbound beacon, start to execute those JNDI or the RMI commands to get code execution. And if you have that single egress control in place, we're not going to be able to execute steps 3 and 4, and we're going to be able to demonstrate to you that while you may have a vulnerable log4j jar file, you are not exploitable at that moment. So there's a question in here: have we found instances of the latest Schneider power meter vulnerabilities? I don't have that answer off the top of my head, but that's something that I'll have the team go off and look at and get back to you, Michael. And just make sure you ping me on LinkedIn, and I'll post that out as an answer. But I'll have to ping the attack team for that one. So I'll leave you with a set of resources. So there's some great technical content out there on Log4shell specifically, and then a variety of attack techniques on the attacker blog. And the key point in this entire talk is that being vulnerable doesn't mean you're exploitable. And there are a whole bunch of ways to fix Log4shell in terms of updating the jar file or the egress control. But you have to go through and verify that you are not exploitable to this particular attack, number one. Number two, realize that Log4shell isn't the destination, it's the starting point. And it still comes back to, once the attacker gains initial access, making sure you've got the basics implemented of preventing credential harvesting, preventing credential reuse, making sure OS credential dumping is turned on at your endpoint, being sure that you can detect and respond to malicious or unusual logins and other tactics like that. So I'll end there. So I promised I was going to keep this at 30 minutes. If you guys have questions, you can post them in the chat. We can open it up for a couple of questions here. Otherwise, we can take the dialogue to LinkedIn, where I'll post the recording and the slides, and then we can converse through the LinkedIn comments there. So thank you for the time. I hope you guys found this valuable, and we'll catch up with everyone in 30 days at the next Tech Talk.